And hey everyone. So thank you very much for coming along to another IoT Live. As usual, I'm joined by the awesome Cliff Aegis there to my right.
Everyone.
And then we've got a special guest, José Simões. Is that right? Have I pronounced that correctly?
Yeah, close enough. Yeah.
Yeah. I'm not going to get kicked off the stream, hopefully. Yeah, I mean, it's funny we having a conversation about pronouncing names. I think I said your name, pronounced your name incorrectly, Cliff, for the longest time. I think I was calling you Aegeus for ages.
Yeah. I don't even hear it anymore. It's like my mid-40s. I just do not hear it. It's like everyone gets it wrong. The weird thing is, I always hear it when someone gets it right, though.
Oh. Right.
So it pings. Oh, they got you right. Hey.
Yeah. That's pretty much just the flight attendants and your mum that get it right now, though. Everybody else is just.
They definitely don't get it right. Yeah.
Oh, geez. So, tonight is another special episode, and José has come along, and José is the founder of the NanoFramework, which is a way of using C# on microcontrollers, which is fantastic. And we have like a 15-minute prep period, and we've deliberately not spoken to José during that whole time. We've just muted each other, and it's funny.
It's hard.
It is, yeah. Otherwise, we end up asking all the questions before the stream starts, and it takes away that natural conversation. So, yeah. So, yeah, thanks very much, José, for coming along and speaking about NanoFramework. Did you want to introduce yourself and say what it is you do?
Sure. Thank you for having me. My name is José Simões, as Peter presented me. I'm the CEO of Echo Solutions. That's a company that works on embedded systems and software development. We work mostly in the monitoring solutions for cold chain industry, and also do some custom projects for customers, developing products from electronics to firmware, IoT, and all that stuff. That's why the NanoFramework started back in 2016, when we were already users of MicroFramework, but he ended up defunct. So that's a history that we can go through there. But that's how NanoFramework showed up, out of the frustration of MicroFramework going nowhere. So that's how it all started.
I like it. I thought Cliff was going to ask a question then.
I was going to, but then you was going to. So
after you. No, after you. No, after you. Go ahead, Cliff.
I was going to... The MicroFramework obviously went across and got taken up by the team over at Wilderness Labs and kind of lived there for a wee while before obviously they dropped it in favour of the Wilderness Labs boards. Was you not tempted just to follow that, or was it a case of you wanted to see a new start and take it in a different direction anyway?
No, if I remember correctly, we kind of started it at about the same time, without knowing it, because for actually there are I would say 3 variations or spin-offs. Two. It's us, NanoFramework, the Wilderness Labs, and the GHI. Which are the three options that you have if you want to code in C# for microcontrollers. We are kind of the continuation of the MicroFramework spirit. Keep it open source 200%, and they are based on Mono. If I'm correct,
the Wilderness Labs one is, yes,
yeah, and we picked it up where MicroFramework left. Basically, what we did was to get rid of what was not so good there. We completely revamped the build system, which was dreadful. We took the good parts and we kept developing them, and all this basically started in August 2016. It was me and a couple of more guys, and we started this kind of on a private GitHub repo, and by the end or early January 2017, we did the public announcement on the micro framework, on the nano framework. Sorry.
So if Wilderness Labs run theirs, I'm talking about this because we had Brian last week from Wilderness Labs. So Wilderness Labs run theirs on mono.
Mm-hmm.
What does yours run on then?
It runs pretty much on everything that you want it to run. That's one of the main differences on all three of us. We are platform agnostic completely, opposite to the other two offers. And that's one of the things that we choose to do is that we extracted the CLR, the execution engine, completely from the RTOS that it's beneath. So basically, what we have now is some. It can be compiled as a library if you want. And we need two threads of an RTOS, one to run the CLR and another one to run the wire protocol, which is the layer that communicates with the Visual Studio or the external tools. Apart from that, and it's completely separated. That's why we have it running on GPOS. We have it running on free RTOS. We have it running on the free RTOS version for that ESP32 uses, and we have it almost running on Azure RTOS. So yeah, so basically you can grab the code and plug it on any RTOS that you want.
That's quite impressive. So effectively, it's running natively on the actual. It's using the RTOS that the board is developed for.
Yes, correct. That is completely separated and agnostic. We of course use only the basic RTOS stuff that you need: messages, semaphores, mutexes, and all that basic stuff. Apart from that, it can run on any RTOS that you want, and also the HAL and the PAL. Are also completely separated, meaning that, for example, for STM parts, we can either use the GPOS HAL and PAL, or we can go with the STM CubeMX packages. If we go to ESP32, we use their IDF SDK. For the NXP, we are using the HAL from NXP and so forth. So it's completely it's building blocks if you want.
Yeah.
You just put you take the ones that you prefer, that you are used to, and you are good to go.
Does that mean that I need to use the IDEs that come with like those stacks, or can I live in Visual Studio lands and write my C# there and just publish down to the board?
Yes, you can. You don't need any of those IDEs. Actually, that's one of our goals. I personally use Visual Studio Code most of the time that I'm working there. But you can also do native development on the full Visual Studio. Especially since 2009, our build system is based on CMake, and that's something that it's quite embedded and native right now for our Visual Studio. So you can work there when working on the native side.
So it looks like you've got an extension for Visual Studio that you just go ahead and install that, and then you get a device explorer, and you can select your device, and then you upload the firmware to the board using the Nano firmware flasher.
And that's just replacing the bootloader, I take it, on the device, so that then it's going to run your modified version of the RTOS.
Almost the NanoFramework flasher, or the NanoFF as we call it. It's a command line interface. It's a .NET tool, which basically connects to the board using whatever it needs, because there are targets that you connect using JTAG, others to the FU, others like the ESP32 using the serial port. All that is covered in the tool, and that's used to do the initial flashing of the device, because as soon as you have that, you can do the updates through Visual Studio.
That's very cool. It's very impressive. It's a lot more impressive than I thought it was when I kind of heard about it and kind of read a few bits about it, but never really got around to actually looking deeply into it. So yeah, I sort of tend to use a lot of, just on the projects I've been doing recently, a lot of Tinsy and Adafruit boards, just because they fit the form factor fits what I've needed to do for clients. And the code is written in Arduino C anyway. So to see this and actually think that I could bring it across the .NET land, would be awesome. So what is missing from .NET then, or do I have everything? Can I bring in NewtonSoft.json and all the other packages and things like this, or is it the fact that I have to stick in to where I am with just the core?
The biggest limitation is obviously the available flash size and RAM. So that's why, and that's the main reason why you can simply grab an assembly that you build on Visual Studio and drop it on the microcontroller, because it wouldn't fit there. Not to mention the assemblies that you are referencing, that would never fit on any microcontroller out there. So what happens with NanoFramework is that when you are coding a C# project, it's a regular C# project. Roslyn does the build and all that stuff, and the final step, it's a command line that we have, a tool which basically what it does, it grabs the assembly, either it's DLL or the executable, and strips out everything that's not absolutely necessary to run the code. You get a smaller version with almost the EL instructions and the resources and a couple of headers to have the declaration for the types, the class, the fields, all that stuff. And that is basically a mirror of what you have on the full framework. And that's the biggest reason, or the difference, if you will, from the full version.
So he's basically linking it all out, getting rid of all, shaking the tree like a normal linker does, and just stripping out all the parts. Yeah. Okay, that's really cool. That's quite impressive, actually. Yeah.
And you can run it on any hardware or any microcontroller that you like. If there is a port available, you can just grab it and use it. If not, it's relatively easy to do the port, because the build system is very well structured, and it's very easy to find your way through and make a port for a completely new microcontroller or platform if you want.
Which is a nice segue. That's a nice segue into my next question. Yeah, exactly.
And I'll let you ask questions, Pete.
So you've just mentioned there any newer hardware. So what about the Pi Pico, the RP2040? What's the plan with that?
It's I would say that's halfway there, because we want to do a combo with that one. We want to have it running NanoFramework and on top of Azure RTOS. That's the plan there. And there are some bits missing also from the Azure RTOS, which I'm told they are being taken care of. And then we are going to do the final stretch with right now it's doing the yellow word blinking. That's all. So it's yeah. If you just want to see an LED blinking, it's ready.
Perfect. That's it. No, temperature and humidity, surely, Cliff.
Yeah, right.
It sounds like, and maybe you knew this already, but it sounds like perhaps you would have learned a heck of a lot in taking this project on and then having to grow it. Is this something that you were already doing before and you had really good experience in, or have you had to learn all of this?
I learn every day on that, but that's something that I guess we all on this industry can say. But before starting NanoFramework, like I've mentioned before, I was working with C# and C and C++. But I have to learn a lot because this project as a whole, and because it has a lot of moving parts, not only the C and C++ for the native part. On top of that, you have the C# code for the libraries, the class libraries, the base class libraries, and all that, and then you have the tools. From the NanoFramework, the firmware flasher, to the Visual Studio extension, and the metadata processor, which is that utility that I was describing a while ago, that comes after the Roslyn build, which does the shrinking of the assemblies. That's all that is extremely complex, and the hardest one is it's the debugger, the one that sits on and connects with Visual Studio, and for a very simple reason. Until some years ago, that was only something that only Microsoft was using. No one else was doing debugs, so there is absolutely no documentation on that. There are very few people that know the API and what you need to do, and that's one of the major blockers that we keep facing right now. For half a year now, started adding generics there. And right now we have generics running on the execution engine. What was blocking us about 3 weeks ago was the part of exactly the debugger. Because when all this started in MicroFramework, there wasn't even generics in C#. So as you can imagine, that was not prepared or designed for it, and that was a major roadblock on the debugger library, because we simply didn't know what to look for. It's kind of crossing the desert. You want to reach the other end, but there are no signs, no one to ask where to go. It's really hard. But we managed to have some very good information from Microsoft about that, and they've pointed us on the right direction. And so it's just waiting for a time slot to get back to that task, and hopefully we'll have generics very, very soon.
So, go on, Cliff.
No, go on.
Go on.
I was going to say, on the debugging then, have you reached out to Microsoft to ask them, likes of Mads, Chris, I always get them mixed up. Christensen does the Visual Studio, and Torgerson does C#, yeah. Mads Christensen, have you reached out to him and that team to say, look, help us out with debugging, tell us how it works?
No, we are very fortunate because on September 2020 we joined the .NET Foundation, and that was very helpful because when we need to knock some door at Microsoft, we get our life a bit easier because we know someone that knows someone that will eventually reach there, and hopefully we have an answer on our questions, and that's how we got the guidance on how to do this, and at least some hints on how to do this.
Very cool.
I'm just having a look at this live while you're chatting, by the way, and just see.
No, you're very, very brave downloading it live.
Yeah, well, this is good.
Are we going to get some live coding now then?
Maybe. Yeah, maybe.
See if we can get some scrape generating in the background from a sort of ESP32.
That'd work.
Right.
So, sorry if Cliff asked this and I missed it, but what version of .NET is it? I mean, it's a .NET standard version, I guess, but
it's not. Right. This week we just had it. We moved the build system so we could support up to C#9. So we are more on the version of of C# rather than on the .NET framework or version, if you want. Something that was started a couple of months ago is that we are going to have a TFM for us. So we'll be a first-class citizen in .NET ecosystem, which is cool, and will allow us to do more stuff than what we can do today. Because the fact that we don't have a TFM prevents us from doing a lot of stuff. The most basic one, for example, if you want to update the nuggets on the project, what we are doing right now on our pipeline is that we rename our NF proj to CS proj, and then we call NuGet, and it works. And then we rename it back to NF proj. And it works, because if you open an NF proj file, you will see there everything that you see on a CS proj. The thing is that we need a different version of the MS core lib. That's why we can take the SDK or the regular targets of the project system, the C# project system, and we are kind of stretching that as much as we can. But without the TFM, it's very hard to do that. It's something that is being taken care of. It was approved the other day, and sometime in the future, it will be published the NuGet client CLI that will support because that's already there. The PR has been merged, so it's just waiting for a new release.
Right.
And that will be very, very helpful, because there's a thing with Visual Studio extensibility that we suffer from. It's kind of it's frozen in time. We can't use anything beyond .NET 4.7, not even 4.8, which is a major roadblock. You would imagine that you could use .NET Core to do an extension, but you can't. So it's something that I'm praying that will happen with the next version of Visual Studio. Because I have heard rumors that the extensibility system is going to have a major upgrade, which would be great, because right now it's really blocking.
Well, I think the whole thing's been completely rewritten, isn't it? Because it's going to they're calling it Visual Studio 22, is it? I think they're calling it, because it's all going to 64-bit and things like this. So I think they're pretty much starting from scratch, aren't they? Almost. So it'd be interesting to see what they do, because there are things with Visual Studio that need to fix. I do a lot of Xamarin stuff, or Maui is now becoming known. There's lots of issues there where it falls over with Android or iOS, but the two of them when you try and mix them together. But yeah, it's so it's quite so really you're pretty much targeting the latest version of C#, which we can then download onto a board, pretty much like what Pete's got in his hands. What are we playing with? What are we going to blow up tonight, then, Pete?
I've got the ESP32. I think it's an S2, and I bought it and I thought, oh, this is going to be cool. This is new. And then after I bought it, I realised that it doesn't have Bluetooth on this ESP32, so it's Wi-Fi only, which was just odd. I didn't expect it, but this is when we looked at this before, the ESP32S2, we realised it's got some other cool security features on there. But I've got like 3 of them sitting in the drawer over there that I've not used before. But of course, I've got a built-in LED. Not that you'll be able to see this very easily, but most of these ESP32 boards have got an LED, so that's a great way of doing your flash the LED demo project. So I was, while we're chatting, I thought I'd give it a go and see if I can make it work. I'm assuming it'll work.
What's the worst?
The S2 it's not the new one, no.
No, so there's another one on top of that that is brand new. But yeah, this is the one that I bought, which is a secure version of it, but no Bluetooth, which is interesting. So yeah.
If you go to our GitHub on the home repo, you'll be seeing the firmware images that we have ready to flash on all. You scroll down a bit.
Oh, not in samples then.
Samples.
Whoops.
You just need to go back to the home repo.
Let me just pop this in the links for people to see. Hello, what are you doing? Let's put that on the screen. There we are. Devices. Oh no.
You have to go one step back. That's those are the samples, Pete. You have to go to the home repo.
Quite right. Yep.
It's been there, so it's the first one there. Home.
Just there. Yep.
Yep. You scroll down a bit, and you'll see the list of the targets for which we have the ready to flash image.
Oh, okay. I've got it here as well.
If you have those 3-4 firmware packages ready to use.
So
okay.
I don't think the S2 is on that one because the ROM and the rover have a different chip there.
Maybe. Let me see if I can find
but
my
I'm
regular
not 100%
ESP.
sure.
Back in one sec. You carry on speaking, Cliff.
Sure.
So what's the when you're looking at porting? So let's talk about the RP2040. Seeing as that's a project that's going through at the moment. What is it you need to do to make it work? Is it you need to sort of completely start from scratch, or you've already got building blocks that you build upon and bring across to build the build system for that chipset?
Our build system is based on CMake, as I already mentioned, and we have those building blocks, and we have the CMake scripts prepared to kind of plug in new platforms and new MCU families or series or whatever you want to call it. So when we need to first choose an RTOS that's going to support that, and then we add wherever it's required from the linker files, implement the bits that are required at platform level for the various calls of the CLR, and we don't need to do that all at once. The typical one that you start with is GPIO to see the LED blinking, and but even that is not required because we just need the timers to have the clock running. We need either a UART or the USB to get the connection to Visual Studio. And apart from that is wherever you need, you can use the usual stuff, SPI, ASCII, PWM, all that. Networking, wherever.
So that explains why when you if Pete scrolls down the charts and clicks expands, you've got that little nice little just underneath that table, Pete. There's expand, click to expand there, and then you've got the check boxes of all the different things that are implemented for each of the different chipsets and platforms.
Correct.
So it's quite impressive. I mean, it's mostly chips, isn't it? So it's impressive that all that is being done, and then how do you target this in C#? Because obviously, C#9 doesn't know what GPIO is. So using the .NET kind of GPIO framework, like the .NET IoT, I've forgotten what it's called, Pete. What's the name of the library?
NuGet package, the devices, system.devices.
System.devices. Yeah. Using that, or do you have your own NuGet that's pulled in to target those?
We have our own NuGet because of that same reason. The assemblies wouldn't fit in the microcontroller. Okay. What is happening, and that's a good question. When NanoFramework started, we choose to. Our thought process was kind of this: we don't want to reinvent the wheel, and designing an API is hard. So what makes sense to tackle this? And what was available back then was the UWP API, which brought a lot of stuff from IoT namespaces, and that's what we started to follow. That was betting on the wrong horse because that's gone now. And so what we started about 1 year ago. We got friends with .NET IoT Core, and what we've been doing, it's aligning our API. So basically, we have this almost in pair with .NET IoT Core. So, and the idea is that you can just reuse code from both platforms. Actually, this week is happening kind of a hackathon with some Microsoft and some external people that are working on doing the final stretches on that, so we can have not only the API but also all those bindings that you see there on .NET IoT Core. You are going to be able to use those on NanoFramework, which is very cool.
That is very cool. Yes, very cool. We've got a question from TRP8472 in the chat. It says, so what's the use case for this, and any examples of recommendations where you've seen it used?
Yes, there are a few commercial products using it that we know of. Big and open source. There's no obligation for anyone to report that it's using it, but you can find there on the use case. Right where you are. You scroll down. Yeah, there are case studies. That's one of the published ones. It's being used on products to do some tank monitoring on the US deserts, and it's a box that measures some parameters levels on the oil tanks and reports that through a satellite link. It uses battery and solar, so most of the time it's sleeping. That's one of the nice features of NanoFramework. You can run that for years on a solar panel or just even a simple 3.6 battery. And we have other use case that we know. There's a company in Germany that is using this to monitor solar farms. So this is basically using for telemetry from the solar panels, there are some other uses that have been reported from monitoring systems, some with home automation, things with gardening and all that stuff that pops up on our Discord channel. So that's I guess the adoption is becoming wider.
I like it. That's cool.
Just reading the questions. Yeah, so that's quite impressive that it's been used by quite a big organisation if they've got these things out in the middle of nowhere. And are they just running that? The picture of the board that Pete flashed up there isn't like a ESP32. Is that something they've built in house, or is that it's just they've got an ESP32 in the background? Do you know?
That one on the oil fields is using an STM32. It's an F7, I think.
Okay.
But it would work anyway.
Cool. And you mentioned the fact that the NanoFramework, can quite really go to sleep into it. Is that because it's using the power and the sleep modes that's part of the chipset?
Correct.
So you're just basically saying go to sleep, and it will go down into the micro sleep state and things like this.
Yeah, you set basically you set up the wake me up in X minutes in the future, or you can just use the RTC and set up an alarm, and it will go to sleep, and when the time comes, it will wake up again, boots, type resolution, all that stuff, which happens in a couple hundred milliseconds, and you have your C# application running again.
That's very, very clever. Very cool. I like this a lot. I need more days in the week again, Pete.
I know. Yeah, exactly.
And if let me tell you other thing that I think you will like too. We have two that I consider very, very important tools that make this even more interesting. If you don't know, we have a logging system, which is uses the same API that you have that you are used on the desktop applications. On the namespace, the trace and the log. So you can log to SD card, you can log to serial port, you can log to network or any stream that you want there.
Wow.
This is very handy. And another one, which is mind blowing, we have unit tests.
I just spotted that, and I was like, unit tests. Hold on.
Yeah, you have
on a microcontroller.
On a microcontroller. Yeah, we have unit tests with the same API. This is an extension of the Visual Studio test system. So you can even reuse your unit tests from the desktop.
I suppose at the end of the day, the unit tests are not actually going to get put down to the microcontroller, are they? They're only going to live in Visual Studio land.
No, you have two options. We have a Win32 version of the CLR. It's called the Nano CLR, on which you load the assemblies, and you can do the unit tests on Windows. But if you go and edit the run settings file, and you say that you want it to run on hardware, if you have a microcontroller connected, it will go and load the assemblies and the test runner on the real hardware, and it will run the unit tests there. That's mind blowing. Yeah,
that's goddamn impressive.
Ah.
Wow.
Yeah.
And how much space does that take away from you when you do? How much space does that take away from what you've got? Because obviously you're limited in the first place. So are we losing a fair bit of space doing that, or has it got a small footprint?
It has a small footprint because in the end the test system is not it's not very complex. What adds on the size of the tests are the actual tests, the code that you put there. Because basically what you are doing, you are calling the test classes, the one that have those attributes, And then you are relying on the thing throwing exceptions or just sending outputs to the console, and you are grabbing that and feeding that into the test explorer of Visual Studio. That's basically it.
That's mega. Tell me, I mean, I'm just going through Visual Studio here, so you've been watching me while I've been doing that. But you mentioned you use VS Code, so is there an extension for VS Code to make this work, or is it a bit more manual?
It's you can't do you can't do C# coding for NanoFramework on Visual Studio. When I was saying that I use Visual Studio Code, it's for the native part. When I'm working on the firmware, on the libraries, on the native end, that's where I use the Visual Studio Code. Apart from that, it's Visual Studio all the way.
Yeah, I live in Visual Studio land. I use Visual Micro to get me the Arduino stuff within Visual Studio, and a version of debugging. It's very crude, but it works and it does what I need it to do. But the fact that I could potentially move across to this and get, a better version of debugging and a test runner as well is very intriguing. I just need to persuade my clients to let me move away from the Tinsy boards that they keep giving me and saying we want these in our projects.
And when you say debugging, it's the full debugging experience that we all know and love on Visual Studio.
Wow.
You can set breakpoints. You can go back and forth in the code. You can change the variable contents and all that stuff. You can see the locals. You can set watch points. Whatever you do on debugging a desktop application, you can do on NanoFramework.
And how's that working then? Is it literally looking at the memory within the chip, or is it there's a bit of code in there that's sending the data back, or is it
because this is .NET. What happens is that you are executing the equivalent code IL instruction. It's a stream of IL instructions that is running on the device. So you have the execution engine which communicates with Visual Studio, and it will tell it if it has hit a breakpoint. It can query the variables. It can go through the type system. Whatever you want to do, you do with the desktop debugging, you can do exactly the same, because there is a tiny execution engine and CLR running there, which does exactly the same thing that you found on the desktop.
That's quite impressive. You mentioned there's a Win32 app a moment ago. Does that mean that you could test this all your code offline without needing the device, like a hardware device?
Almost. We are that's the next step, because what happens is that you have the Nano CLR as a Win32 application, and the way that you load the assemblies there is using the command line. So basically that works as a command line. You pass a bunch of switches there to load the PE files, and it will take them and execute. That's a very handy way of debugging the CLR, actually, because you can do that on Visual Studio. It's much quicker and much powerful than doing directly on the microcontroller. The next step would be to add that layer that allows Visual Studio to communicate with it and do the usual stuff from the deployment to the debug session, the setting breakpoints, querying the variables, and all that stuff.
I only ask because I travel a lot, and being able to travel without having to take hardware devices with me and explain those to security would be awesome. It'd be really nice.
That's not far, and you are not the first one asking for that, and that's something that's on our to-do list, and we'll get there. Yeah.
You mentioned it a few times. You said our to-do list, and we're looking at this and we're looking at that. How big is the team that's looking after the NanoFramework? Is there a core contribution team? Is it a big team, or is it just a handful of you?
It's a handful of us. Right now, we have been having some extra help from a great guy from from the IoT core team, and which is doing a lot of work with NanoFramework, which has been great. But apart from that, it's a very small team. I'm doing most of the work there, and then we have some spot corporations from contributions from the community. Which there have been some more people willing to step up and contributing, which is great. And they are getting their feet wet on this. They are starting to get their way around, and they are willing to contribute and have fun in the process, which is great.
Cool. I think I'm gonna have to do what Pete's doing, play with this a bit more, and get my head into it, because it's a very, very intriguing way of using .NET.
It is.
We all know and love as developers, but being able to use it on a device that's so low powered. A lot of the projects I do for clients are just like that oil farm. They're out in the middle of nowhere collecting data and sending it back via Wi-Fi, LoRaWAN. I've done projects where I've been on ships at sea and using the U-Blocks satellite system to send a packet of data back. Which is quite expensive. It's not cheap to send a packet back via satellite. It's 10 pence per byte when we was using it. You learn to bit bang. Turn that bit on for, which means that and that, because you only want to send 1 byte and that. The good thing is you get the GPS location and the UTC timestamp for free, because it tells you where the data was sent from and at what time. So that was handy. So you didn't have to send that data, but being able to do that in .NET rather than Arduino C, which I know how to do, but it hurts my head.
And
it's fraught with danger. I mean, C is it's great language, but you can quite easily blow your feet and your legs off with it quite quickly.
Oh yes.
I'm very, very intrigued. But as I say, my clients tend to like using the Tinsy or Adafruit boards. I'm not sure why. It's just what they like. I think they've used them for years and they want to keep using them, which is fine.
Sure, which it's fine. Everyone likes what it likes, so that's fine. Speaking of the Arduino code, something that's interesting too. We have interop, meaning that you can reuse C code and expose it to C#. Meaning that all the libraries that you have on C, you can wrap them on C# and call that from the C# application.
Wow! So is that like the pinvoke kind of?
It's kind of, because the mechanism is basically the same. What you do, you start from top to bottom. You start with your C#. You start with your C# application, the wrapper, let's call it that way, and you put there the methods that you want to connect to the C code. And what Visual Studio does, it builds the project for you, and it generates some stubs, which are C++ and header files. And then what you do, you grab those and you put them on the build system, and you fill in with your code, and you call the C APIs or the C code that you have there, and that's it.
That sounds quite simple, actually, and quite intriguing, because that does mean that the libraries that have been written can just be reused. That's awesome. I like that.
Indeed.
Yeah,
this is something very, very powerful, and from coding, on which you have the IntelliSense and all that good stuff, from to the debugging experience that we all know and love. This is light years ahead of any Arduino that you find out there.
Yeah.
So just looking at,
and it's .NET.
It's nice. .NET, yeah.
Just looking at this example I'm walking through here, it's saying that we need to use windows.devices.gpio, and then we grab the sample code this Blinky sample code, which is here. But actually, the Blinky sample code is using system.device.gpio rather than windows.device.gpio.
Yeah, that's because of our extensive team, our documentation is usually lagging because
that's okay. So I've switched this to windows.devices.gpio because that's what I'm using, and then obviously I've broken stuff at this point, so I'm not entirely sure what I'm doing now.
You have that.
Make the font a bit bigger, Pete. It's a bit.
If Pete, if you want, you can grab the Blinky sample that we have on the samples repo, and that one is already using the system device at GPIO.
Yeah, so that would be better than using the Windows.device. So maybe if I just switch my package, actually, if I get rid of that one and then
you can do that.
Yeah, let's just do that. So use this one instead, system.device.gpio.
Yes. No, that one that's for the .NET Core IoT.
Okay.
You have to grab the one that starts with NanoFramework.
The one below.
That's the Windows.
That's the Windows
That's
one.
Still the Windows, but you'll find there if you type there nanoframework.system.
NanoFramework.system .gpio will be there somewhere. Let's go past it. No.
I think the package manager was that from the download account, so that one is still not that.
Must be this. That's that one, isn't it? I would imagine.
System device, yeah.
Yep. Awesome.
Yeah.
And this is your fork, essentially, of the system.devices.gpio for NanoFramework. Is that what it is? So we're looking at.
It's not. It's a mirror of the API. It's not so much of the fork because the code beneath is it's different.
Right. Yeah, that makes sense then.
So you're matching the API kind of framework,
yes,
but you're filling in. So you're stubbed out for you, but you're just filling in the blanks with what needs to be done for each of the different. And are you having to do that for? Is that kind of generic across all the chips that you currently support, or are you having to do one of those for each of the?
I would say that half. The upper layer is always the same, and then you have to call the API specific for each SDK because each vendor has one, but they're not that different. So it's a matter of filling in the blanks, and you call the right APIs.
I like it.
So where's the project aiming to go? What are you aiming to get to in the next kind of few years? I mean, you've got the backing of the foundation. You're kind of getting noticed by Microsoft. Quite a lot I've noticed on the likes of Twitter and talking to others at Microsoft. So, where is the project kind of aiming to go in the near future?
We would like to become a first-class citizen on the .NET ecosystem, which is already happening with the TFM and the fact that we are going to be, as soon as we have that, we'll be able to have SDK-style projects, meaning that we'll be on pair with .NET 5 or 6 because there is nothing preventing us from there. The idea is to have the API always as close or exactly the same as the full framework. And the only things that you won't find there is that you won't have so much method overloads because they either don't make sense or we just can't have them all. Otherwise, it wouldn't fit there. So we are careful with the ones that we choose to implement there. But that's the main goal. I would like to see this known by more people and used by more people because this is incredibly powerful. And I mean, this is from if you are learning to code at school, or even if you want to come up with the proof of concept, if you are on a company, this can be easily done in a couple of hours or minutes with the NanoFramework with .NET. And it's something that it will take you much more time doing with Arduino, and if you are going with C, that will take you a full month to have something.
We've all worked on projects that have been proof of concept in Arduino C, or even normal like C and C++ for IoT, and they die because the project runs out of money at the proof of concept stage, and it is not shown that it's worked because of, you just not had the time, and budget to put the time in to make it work. Whereas to be able to do it in C#, I can think and code a lot quicker in C# than I can in C.
Yeah.
You haven't got to worry about hanging yourself by a memory overrun or anything like that. So yeah, that is really, really, really interesting to me, and certainly something I'll be looking at in a lot more detail. When I find more days in the week. But yeah, it's it's quite impressive. Is there a plan to add more? Obviously, you're working on the RP2040. Is there others that you're working on that you're planning to add? Are there other maintainers that are looking to add more into this, or?
Yes. We plan to, along with the Azure RTOS, we'll bring in the IoT board from ST, the L4, which is one of the demo ones that is being used on the Azure RTOS. And another one which will bring also a new platform along. It's a new chip which is from Maxim, the Max 78,000, which is I don't know if you ever. Yeah, you have one there, Pete.
Oh no, I have to say that
you've got blinking LED.
Oh, you have a blink. Yeah, congratulations.
There's two different. So I've got José and Cliff up on my phone up here, so I'm waving them and also waving to you lot there. So so that was the hello world there. I'm assuming that is the correct flash pattern that you'd expect from your blink. It looks like it in the code, rather than something else.
Three short blinks and
the longer blink at the end. Yeah, you got a slightly longer sleep at the end.
Yeah, 525. That's it. Yeah, so it's working. Awesome.
Yeah.
3 blinks and a sleep, and then 3 blinks and a sleep.
How about that? That's pretty cool.
You see, it took you more time to switch the nuggets than to actually.
Yeah, it did. Yeah, most of it was faffing. I went and picked up another device. I thought, that'd be it, but I think this is an ESP8266 actually that I picked up. That's not going to work, and obviously the S2 we think might not work. But yeah, this is a Heltec device. Let me just get that on the screen so you can see what it is that I got a while back. I actually sent to Liam Gulliver and Jonathan Relfer sent one of these.
Okay.
So it's got a built-in OLED. And I just had to figure out which pin. So it's a Heltec device. So let me get let me get this up as well.
I remember this one. Yeah.
I'll stick it in there.
You spoke about it before, yeah.
So yeah, it's quite cool actually. Little OLED on there and everything. So it was cheap, so I thought I'll get one of those, and I'll get one for Liam and Jonathan as well. I might persuade them to do an IoTeaLive using something like this. So now that I know that we can do C# on there, there's a good chance that we could use that, but I don't think we'll have any way of driving that OLED directly, will we? There'll be no package that'll let me drive that OLED. That'll be something that I'd have to write.
Yeah, we can. We have a library for UI, which brings in several of the system drawing namespace. Colors, you can drive all that. The one of the most powerful boards that we have a ready to flash image, it's the STM32F769 as a discovery board with the quite large LCD, color one and all that. And we have a demo with a Tetris game there, for example.
Wicked.
So it's very cool. So we have UI too. It's not something very requested. I mean, it is and it isn't on the embedded world, but it's there too.
Oh, that's cool.
Wow.
I'd like to play with that.
What about now Pete's brought it up? What about all the kind of libraries to drive like a temperature and humidity sensor? Is it just you're relying on the low level GPIO, UR, SPI, and you write the library to go with yourself, or is it there's another part of NanoFramework where somebody's already written a library for that sensor, that motor, that board?
It's a mix of all that. Apart from the standard SPI, I2C and all that stuff, you have there on our GitHub the community contributions that has a growing list of drivers and utilities and libraries that developers choose to contribute there. And sometime next month, when we do that. When we complete that run with .NET IoT Core, we'll be able to use most of the bindings there. And so wherever it's there, you can also use on NanoFramework, which is pretty cool.
There's a quick question for. Did you already ask this? But Chris C. Swim says he's just catching up and he's assuming that Azure RTOS exists because Amazon bought FreeRTOS. Did Amazon buy it? I thought it was Google that owned FreeRTOS. I forget now. I lose track of who owns what RTOS these days.
I think it's Amazon.
Yeah, there we are then. Yeah. And he says he likes the TT Go T display. He managed to bag a few on Banggood for $5, which is a bargain. Free delivery. Nice IPS display and LiPo charging. Yeah, well, that's pretty cool. So this community contributions, we've got drivers, libraries, and utilities in there. So ESP32 storage.
Yeah, I've just gone into the drivers. There's like keypads, there's OLED displays, RFIDs, there's sensors, shift registers, stepper motor drivers. There's quite a few things in there. Yeah. MP3 player, TFT display, storage. There's the BME 280, so you can quite happily do your.
Cliff hates temperature and humidity. It's not.
The only reason I hate it is because no matter what documentation you look at, no matter what IoT 101 project you look at, is always temperature and humidity. And I'm bored of it. I want to see something that actually does something. If you used to take temperature and humidity sensor into school and teach kids and say, look, now it's getting hot, now it's getting colder, now it's damp because you breathe all over it and you've got damp air coming out your mouth, they're not going to be interested. If you've got like a motor driver that moves a robot, then they're going to be really, really interested really quickly. Yeah. And that's what, for me, is if you're going to do a demo of some kind, you need to think of it that you want to get someone's interest, not bore them with temperature and humidity. So that's why I hate temperature and humidity sensors.
I understand what you're saying. And speaking of Unity, we pulled something also very interesting the other week. I don't know if you are familiar with the UnitsNet library.
What? Sorry?
UnitsNet. The same on the same word. It's used extensively on the .NET IoT Core bindings to take care of everything that's unit. From electric potential to resistance, whatever you have on the IC, on even on the Imperial system, it's there, and take care of all those nuances and complicated math that you find that you have. It's taken care of, and because that was required for the bindings, we went there and made the code usable on the .NET NanoFramework. So now you find a bunch of NuGets for the individual units. With the full framework, you have a single NuGet with all that, and it's pretty cool because it takes care of all those for you.
So all the conversions, Celsius to Fahrenheit, and
that's
stuff. Yeah, all the stuff.
From the basic stuff or the most complex ones. If you type the units.net, you'll find it on GitHub, and then it gets to you.
Units.net. Is that what it is?
No, it's all same one, the same word. Units.net.
Okay. Cool.
Yeah, that's the one. That's a pretty impressive library.
Yeah.
Static typing. Oh, okay. Okay.
It's very cool.
So, can you convert from like Celsius to Fahrenheit and things like that? Is that
that's the basic stuff? Yeah, but you have there from you have a calculation there for vitamin C. I saw the other day.
What? Oh no, culture. Oh no. Oh, that's terrible. That's always going to go wrong.
That's quite a powerful library, actually.
It is.
You can use that in any .NET package as well, because it's Net Standard 2.0.
Yeah.
That is awesome. That's awesome.
It is. And you have nuggets for NanoFramework too, since last week.
Yeah, I just noticed that. Yeah, it's got NanoFramework in there. Net Standard 2.0, Net 4.0, NanoFramework, and the Windows Runtime component for GWP.
Those are being used on .NET IoT Core bindings for ages.
Oh, I like that a lot. Actually, I've just started that project because that's I need to keep an eye on that one because I do a lot of funky maths and I'm bored of doing the conversions. Certainly when you're doing lat long conversions, but you're doing it with a vector and you're trying to work out drives you bonkers. You're trying to work out a vector across the Earth, which is an oblate spheroid. So it isn't quite a distance in meters or miles or nautical miles. You have to, changing longitude times the cosine and latitude is the it hurts.
Yeah, you have to brush up your trigonometry.
Chris C. Swims asked a good question there in the chat. Is there actually any minimum spec that you can use for a device that supports this? What's the minimum RAM and stuff like that?
That's a good question. We have this running on the smallest device that this is running. It's the STM32, the F0, which has 128 Ks of flash and 68 Ks of RAM.
So it's quite small. It's not a lot.
It's not a lot, yeah. It obviously you can have their PWM and GPIO and networking and a bunch of stuff. You have to go with a small application too, but it's pretty usable.
What's an ESP32 got compared to that then? I forget now. It's quite a fair bit, isn't it?
It's a lot more, and especially because it has an external flash and it can go up to 16 megabytes.
520K RAM. 448K.
Yeah, it's quite big, isn't it? The SP series.
Yeah, that's a powerful device.
Yeah. For the amount of money you pay for it, I mean, you run your risk of what dodgy version you're going to get and how well it's been soldered together when it arrives from somewhere in some factory in China. I've had some very good boards, but I've equally had some horrendous boards that were dustbin material when they arrived. So I know that's one of the reasons that one of my the client I mentioned likes to go with the Tinsy and the Adafruit is because they've seen too many bad boards from the ESP range. So they've gone with that because both those boards are made in the US and they trust the fact that they've been made correctly. But yeah.
And that's important. If you are an hobbyist and you are doing that on your garage, that's fine. But if you have a commercial product running there, you don't want crap.
No. Chris C. Swim has followed up there with how much do you have left on that STM32 F0 for user code after you've got everything installed?
That's a very good question, and I can't remember that from the top of my head. But I would say that 1/3 is for the CLR, and the rest is free for the application.
Well, plenty then.
It's quite a lot.
tiny.
With it is. That's something that we had to do for targets like those on which we got unlike the micro framework on everything was in a single package. We extracted that as all that we could on individual nuggets. So you can only take what you need for your application. Meaning, for example, an obvious one, we extracted the system math. It's a separate library, and we have two flavors of the MS-Core one that supports reflection and the other that doesn't. As you can imagine, that removes quite a substantial part of the API and the code that's beneath, and that allows it to run on smaller devices.
Very, very cool.
Everything is optimized to the maximum possible extent to squeeze the last byte from there.
I can imagine. Out of interest, so I've got this. Obviously, I've deployed my code and it's busy flashing. Can I just like set a breakpoint and and how does that work at this point? What do I need to do to get it to hit that breakpoint?
F5.
You have to
literally run it
to start the debug session. Yeah,
as simple as that.
Something that you cannot do, unlike you do with a desktop application, you cannot attach to a running target.
Right.
You have to start from the beginning, and the reason, we have to keep in mind that's a small constrained device. It has to. It's there, boom.
That's awesome. And do you get inspection as well? You do.
Yeah. Everything.
That's awesome.
And if it's not read only, you can also change the value.
Really? I mean, I can change the pin number.
But the LED toggle, I think it's But I would advise against that.
Yeah. Let's not do that.
That is awesome.
That's really cool. How cool is that?
That is, of course. That is awesome. Yeah, I need to look at this a lot more.
It's pretty cool.
C# and an ESP.
More people should. Yeah. More people should know about this because this is it's very cool. Learning .NET C#, it's not only the productivity that you have, but also from the learning experience, it's much easier. And it's time that the embedded systems industry gets past that established thing that if you want to do embedded, you have to do it on C. No, you don't. You can do it on .NET C#. This is not the holy grail, and that everyone should be doing this. No, there are use cases where C and C++ still has to go there. If you want to squeeze the last milliamp from a battery, if you want to get really, really optimized, if you want to go to really, really tiny devices, you can't do C#. For that, C and C++ will still be valid and perfectly fine. But for most situations, from a scale even to traffic lights, you can home automation, whatever. You can do that on C#, and you can reuse codes that you use on your desktop projects. You can have the unit tests there. You can have people that are desktop developers that with very few training, they will be able to code for embedded systems because all the complications and all the hard stuff is abstracted from them. And they only have to look at C code. And that's awesome.
I'm also thinking it's a great learning platform for children, college students and the likes, because, the problem with doing a C# kind of Windows application is you've got to get past Windows to display something on screen, a button and that sort of thing. And then it's just an icon that's on the screen. It's nothing fun. Whereas I mentioned before, if you make it fun, the kids are interested. So to blink an LED, great. To move a motor, which then means you can make a robot and, Pete's done this. He's got one behind him. It's you can move a robot arm. You can then suddenly start controlling things, and that suddenly gets kids interested.
Can we do Signal R? Can we pull the Signal R library down, or is that just too big?
I can say that yes, sometime next week or the other, we are going to release the WebSockets library. And a few weeks after, because it's already on the final wrap, we will be releasing the Signal R library.
So I can replace my Raspberry Pi with an ESP32 and Signal
You
R.
can have them talk to each other, yeah?
Yeah. Oh, how about that? What PWM have we got on this? I forget what PWM you get on these things. Where is it?
It has a few ports there, yeah.
Yeah, I think it does, doesn't it? Oh, I've lost my page with all that. But that's because it's
here. Kiwi Bryn says he uses, or it could be a share, I don't know. They use, we'll stick to that, shall we? .NET on small platforms teaching IntelliSense and hardware makes it way more interesting. It does. I think it's a way to teach coding to kids that's a lot more powerful than spinning up a console app which asks them for their age and then displays their age, or spinning up like a complicated Windows, even Windows Forms. WinForms is still a fair bit to get them lost in. But this, is a few lines of code. It looks like and smells like a console app, but it's running on a small little embedded platform. It's very, very powerful. I like it a lot.
Yeah, and with that new stuff that C#9 brought, that you can have just the application,
the top level programming.
Without all the ceremony from the namespaces and all that stuff, and which makes it even cooler to if you just want to write console. Yeah. If you want to go just the console write line, hello world, you can do that with a single line of code. How cool is that to learn something?
We do that. Where does that come out through the serial port? That console.
No, he's basically saying that
it will the debug write line will show on the Visual Studio output.
Oh, yeah. I see. So is it console.write line or is it debug?
Debug. It's debug.
Is it capital debug? No, why can't I see that? Why has it got no IntelliSense?
You are missing the using.
Yeah, just put it in and control dot it.
Oh, okay.
Right, debug and the
so it's got it now. Weirdly.
Yeah. And it will show on the Visual Studio output window.
So I can just run that. And I should.
Kevin has done a couple of libraries using LoRa for several of the devices, so he's a good friend of the project, and he has done a couple of extra I/O projects too.
This is mind blowing.
It's awesome. Yeah.
I mean, I've seen the project. I've had a few kind of looks at it, but never realised that it was as powerful and as good as it is.
Hold
on. That's mind blowing.
It is, and it's the fact that it's platform agnostic, unlike all the other options that you have, makes it more powerful because you are completely free from the hardware. That's easy for the users. That's a lot harder from us because instead of having a single well-behaved platform, we have to deal with pretty much everything. From nasty drivers, which happen a lot with ASP devices. I mean, if you have one with the ASP serial converter from FTDI, that's fine. The driver works and that's fine. But as you move to some Chinese crap with the driver and the chip, it's a nightmare to have that working. And we have to deal with all that, makes it more difficult. But we are there.
Yeah, I'm gonna. Yeah, as Kiwi Bryn said, best project to get students interested. It's something that I think I'm gonna look into. I sort of was helping the kids pre-COVID at school, where my two sons go to teach them a bit of coding, and he's always doing things in Python and and stuff like this. It was okay, but they got bored real quick.
It could be me, but Python bad.
Yeah, but to take in, I mean, the robot that Pete's got behind him is 3D printed with a couple of 9G servos on, and it'd be dead simple to cut and get working. And as Pete says, showing the robot off, that would be really, really cool.
And speaking of a learning platform, there's a project that it's about to go on Quickstarter that is using an ASP32. It's I think it's from Sri Lanka. If you go to magicbit.cc,
magicbit.cc,
magicbit, BIT.
Yeah,
you'll find there a very interesting platform for learning, and they are about to release this, and there will be libraries for .NET NanoFramework.
Oh, look at this!
Oh,
if you scroll down, you'll see there the kitten with a bunch of sensors. You have that for a learning platform running .NET C#. This is way cool.
Look at this! Look at that! Wicked.
Where do I back it?
Yeah.
So a few discounts being launched on Kickstarter. I'm putting my email address in as we speak.
I like that. That looks cool.
Submitted. I've only got to wait 27 days for Kickstarter to open, and then however long it takes for it to actually,
So this is me doing the disclaimer. I'm not endorsing them. I'm just saying that they are going to have .NET NanoFramework libraries there.
Yeah, that's very cool.
It is, and if this gets through, I think it will be a great platform for learning. And
yeah, definitely, it looks like they've covered the bases with simple things like a little robot car and stuff like that.
And the basic sensors, you have the ultrasound, distance, all that stuff that you are used to.
Cool.
That looks that's pretty cool. I like the look of that.
Yeah.
And they even have a robot there somewhere. I think I've seen that there.
Yeah, they had that on that first page there. They had one in that little demo.
Something with the wheels and motors and all that.
Yeah, I'm well aware we've run over by 20 odd minutes.
We have. It happens regularly.
Any more? We've gotten carried away again. Any more questions from everyone in the chat that we'd like to put across, or any other kind of final thoughts from you, Jose, to say about NanoFramework? We all know where to go on the GitHub and look at that. I'm certainly going to dive in. I've got a bunch of SP32s in the workshop that I'm going to dive in with as well. So, but yeah, this fantastic project.
Yeah, that's awesome. That debugging. How easy was that? That was cool. I think that was my favourite bit. That and console.debug.writeline or whatever. It was simple. The instructions worked really well as well. So there you go. Yeah,
indeed.
Yeah, really appreciate you taking the time there, Jose. It was really good of you to come on.
Thank you very much for having me.
And do keep in touch. I mean, obviously,
my pleasure.
I've got a sister meetup group that we do a more talk-based event at. So it'd be awesome to get you along and do a proper set of demos and a talk about NanoFramework to that at some point later in the year.
Sure.
So I'll bend your arm later on Twitter about that. But yeah, so thanks.
All right. Mention reaching out to you though. Obviously, your Twitter handle is below your name on the screen there. Where else can people find you? You mentioned a Discord channel earlier.
Oh yeah, that's true.
Is there
if it's all if you go to the website nanoframework.net or to our GitHub, that will be github.com/nanoframework. The Discord channel, the link for the Discord channel is there. So please join. Ask questions there. We have a very friendly community. Everyone willing to help, and a bunch of people there. and also on Twitter, we have that repo on GitHub with a bunch of samples there. 100% it's open source, from the native code to the C# libraries, to the Visual Studio extension, the tools, everything is there. So you can pick around, you can get ideas, you can fix bugs. Please do. We love PRs. So
one last question for me though. When do we think we'll be getting the RP 2040 to a point where we can tinker and play with it in C#?
That will be after generics, because that's on the to-do list for longer. But I was going to say before the summer, but that will be too tight. So I guess sometime after the summer, we'll be there.
Cool.
Fantastic.
I might dive in and look myself. But yeah.
Love it. All right. Well, thank you very much again, Jose, for coming along. And thanks to Cliff again, obviously. So we will be back actually on Thursday. Cliff in this country for once will be continuing his journey with the NVIDIA Jetson Nano, along with Paul DiCarlo. So yeah, and I've got my boxes sitting in behind there. The Nanos, actually, I moved it across the other side of the room.
I'll have a bigger keyboard than this one this time.
Yeah, thank God. It was the mouse, I think, that was more frustrating than the keyboard.
Well, you've only got a little mouse pad. I mean, my finger's bigger than the mouse pad, but yeah, the buttons are. This is what I have to travel with when I go and do IoT with boards, and I'm traveling with a little mini keyboard like this. But yeah,
awesome. I like it. So yeah, that'll be 2 p.m. BST on the same IoTeaLive Twitch channel. So do join us for that. That should be quite interesting to see where we get to with that this coming week. And then again, we'll be back at 9 p.m. BST next week for another IoTeaLive. So thanks to everybody in the chat for contributing there as well. And we'll see you all again Thursday. Cheers.